Hello guys, it is me, Mr. Van Lowe, and I am going to show you how to add vectors quantitatively using both visual addition, using diagrams of the vectors, and algebra and trigonometry. Okay, so I think putting the two methods together is a useful approach here, as we will see. So the first thing we should do is define our vectors. So here I've defined two vectors, vector A and vector B. And note that the direction of each of these vectors is given by alpha for A and beta for B. See what I did there? Clever. Okay, so we are going to add these two vectors such that A plus B is equal to C. Okay, so step one. Arrange our vectors so that they are tip to tail. You may recall in a previous lesson we also showed the parallelogram method. That's also fine. However you want to do it is up to you. So we're then going to draw a line from tail to tip, and this will give us our resultant vector, vector C. There it is. And I've given it a nice hot pink to show that it's cool. So in step 3, we will add together our horizontal components, and that is how we will get the horizontal component of vector C. So as you can see here, I have drawn the horizontal components of each of my vectors. So there's a horizontal component of A, the horizontal component of B, and the horizontal component of C, shown graphically. Now, we can visually represent those horizontal components like this. So horizontal component of A plus the horizontal component of B is equal to the horizontal component of C. And this seems to make sense. For this arrow, we are moving to the right. For this arrow, we're moving to the left, but not quite as far. So our resultant component will then be pointed toward the right. There it is. Okay, remember that we can express this algebraically using this formula. So the magnitude of the horizontal component of A will be equal to the magnitude of our initial vector A times cosine of alpha. And we add a similar looking value for B, the horizontal component of B. So we have the magnitude of vector B times cosine times the angle beta. Okay, and this sum then is going to give us the value of our horizontal vector C. Okay, so there's C sub x. It's all there in the algebra. Okay, so we also can go through the same process for the vertical components. Okay, so here you can see I've drawn now vertical components for each of my vectors, and they look like this. So here is a graphical representation of my vertical components. The vertical component of A sub y, plus the vertical component of B sub y, is equal to C sub y. And if we were to stack these two vectors on top of each other, we would expect that they would achieve a height that looks exactly like C sub y. So far it's all making sense. Okay, here we use sine functions, but the process is the same as before, so I'm not going to bore you with a description. But this will give you the algebraic sum of C sub y. Okay, from here now, once we have identified the horizontal and vertical components of our resultant vector, now we can find the magnitude of vector C using the Pythagorean theorem. Very straightforward. And once we have the horizontal and vertical components, we can find the angle of vector C using the tangent function and the arctangent function. So we take a tangent of theta, the angle that we identified for vector C, the direction, and we divide our vertical component by our horizontal component, and we then use the arctangent function, which you can see here and which you will find in your scientific calculator, and I expect you will need, as most of us have not memorized arctangent tables. Okay, so finally we will summarize a new vector with a magnitude and direction. This is one possible way that you could do that. So vector c is equal to its radius or magnitude, comma, direction. That's fine. Or you could just say the magnitude of c at theta degrees, and obviously you would actually specify these values. Okay, so these are a couple of options for summarization, or, alternatively, if you just show the magnitude and direction somewhere in your calculations, I recommend boxing them so it's obvious what they are, but that would be fine as well. Summarization is just kind of a nice way to go about it. Okay, if you have any questions about any of this, please do not hesitate to ask, and I will look forward to your questions, or perhaps it's also clear now that you don't have any. Hopefully that's the case. I have shared this file with you in your IB Physics Student Resources folder under Topic 1, and you can access it anytime yourself, or you can rewatch this video as many times as you need. Do not like this video. Do not click subscribe. Have a great day.